All right, today we are moving on to graphing our quadratic functions when it is in vertex form. So this is vertex form. We're also going to look at even versus odd functions. So an even function is when you have an equation and you plug in a negative x everywhere that you see an x, and it's going to end up being symmetrical about the y-axis. In other words, when you plug in a negative x, you get the exact same thing you started with. Whereas an odd function, when you plug in a negative x, again, everywhere you see an x, you end up with everything being the exact opposite of what you started with. Okay? Sometimes you're going to get one that's neither even nor odd. That's going to be when part of it changes and part of it doesn't change. All right, so vertex form. Vertex form is really nice because it gives you the vertex. So remember when we had y equals ax squared plus bx plus c, to find the vertex, you had to do the opposite of b divided by 2 times a, and then you plug that back in to find the y coordinate. That was how you found the vertex. That was when it was in standard form. But now, if it's in vertex form, it will give you the vertex. So the vertex is always the opposite of this number, comma, that number every single time. In other words, if we have a minus h, it's whatever just h is, not minus h, comma, k. So that's going to be our vertex. So what does the h do? Well, the h makes it a horizontal translation, left or right. Remember, this is the one horizontal that's always the opposite of the direction you think it would be. Opposite of the direction that makes sense. Okay, so it means if it's subtracting, you're actually moving it to the right, and adding, you're actually moving it to the left. So then the k term, what's being added or subtracted outside of the parentheses, that's going to be your vertical translation. Oh, that didn't write well. Vertical translation. Okay? So that tells you how far up or down. Remember, vertical is always the one that makes sense. It's the direction that you think it would be. All right, so let's start by looking at even, odd, or neither. So to determine whether it's even or odd, we're always going to plug in a negative x everywhere we see an x. If every single thing changes to the opposite sign, then it is odd. If nothing changes, it is even. And if part of it changes and part of it doesn't change, then that's going to be neither. So 5 times negative x is negative 5x. We started with a positive 5x, which means the whole thing switched. So that means this is an odd function. However, on number 2, when I plug in a negative x, remember, always plug it in parentheses. When I square a negative x times negative x is just x squared. Squaring a negative ends up with the exact same thing as squaring a positive. So I end up with the exact same thing I started with. So that means that this function is even. So try number 3. All right, so when I plug in a negative x, when I square a negative number, it ends up being positive again. So I end up with the exact same thing I started with, which means this is an even function. Try number 4 and see what you get. All right, so number 4, when I plug in a negative x, okay, so negative x squared is the same thing as a positive x squared, so I end up with negative 3x squared. So that part didn't change. But when I do 2 times negative x, that gives me negative 2x. So that part changed. The plus 1 didn't change. So part of it changed and part of it didn't. So this is actually an example of neither even nor odd. All right, so finding the vertex and axis of symmetry. If it's given to us in vertex form, our a term is still telling us whether it is a vertical stretch or shrink, so that hasn't changed at all. So vertex form, it's always the opposite of this number, comma, this one. So the vertex of this would be at positive 2, comma, 0, because technically I have a plus 0 there. And my axis of symmetry is still always just x equals whatever the x coordinate of my vertex is. Notice the a term out in front didn't affect the vertex at all. Okay, so number 6, my vertex is the opposite of this one, comma, this one. So that means my vertex is negative 8, comma, 0. And my axis of symmetry is always just x equals and then the x coordinate of my vertex. Try 7 and 8, pause the video, and then come back and check and see how you did. All right, so my vertex on number 7 is a positive 4, 1, comma, positive 4. Opposite of the one in the parentheses, comma, the one that's being added or subtracted at the end, which means my axis of symmetry is at 1. And number 8, my axis of symmetry is at negative 1, comma, negative 5. That's my vertex, and then my axis of symmetry is at x equals negative 1. So the nice thing about graphing it when it is in vertex form is that it tells you then what should be the middle number in your table. Once you know the middle number in your table, everything's exactly the same, regardless of which format it's at. So the vertex on this one is at negative 2, 0, which means that I can plug in 2 numbers smaller and 2 numbers bigger, and then I'm able to find those and solve it. So when I plug in a negative 4 plus 2 is negative 2. When I square a negative 2, I get 4, and 4 times 3 is 12. When I plug in a negative 3 plus 2 is a negative 1. When I square a negative 1, I get a positive 1, and 1 times 3 is 3. I can check the negative 2. Negative 2 plus 2 is 0. 0 squared is 0. 0 times anything is 0. Still works. Plug in a negative 1. Negative 1 plus 2 is 1. 1 squared is 1. 1 times 3 is 3. And when I plug in a 0, 0 plus 2 is 2. 2 squared is 4. 4 times 3 is 12. So when I graph it, I have negative 4 up at 12, negative 3 up at 3, negative 2 is at 0, negative 1, 3, and 0, 12. And there's my graph. So if I'm comparing it to my parent function, well, I know that the 3 out in front makes it a vertical stretch by a factor of 3. I know the plus 2 shifts the whole thing to the left 2, so that would be your horizontal translation. Okay. So let's just get number 10 set up. We won't finish the whole thing, but at least checking and seeing what's going on with it. So I know my vertex. My vertex is going to be at a positive 6, 4. So then if I were setting up the rest of my table, I would be using these numbers. And then the transformations, well, the negative out in front makes it a reflection over your x-axis. The 1/4 makes it a vertical shrink. The -6 makes it a horizontal translation, right 6. And the +4 makes it a vertical translation, up 4. And then we could finish by finding those points and graphing it. All right, so number 11, it says to write an equation without relation to f of x. In other words, I want to know what g of x is by itself without saying what it is compared to f of x. So what is this telling me to do? It's saying that everywhere you see an x for f of x, you're going to plug in an x plus 2. In other words, here and here, we're going to plug in an x plus 2. So I have f of x plus 2 is equal to